second day of 8.1 will be spent just looking at the tangent addition formulas. Instead of just giving you the formulas, I think we could probably figure out one by ourselves. Sine divided by cosine is tangent, so the tangent of s plus t is the same thing as sine s plus t over cosine s plus t. Well, we already know formulas for sine addition and cosine addition, so if we use those to expand the top and the bottom, we get sine s cosine t plus cosine s sine t. And then the cosine addition formula is cosine cosine minus sine sine. So I have cosine s cosine t minus sine s sine t. And so to simplify this a little bit further, and probably something you wouldn't expect to do, but the trick is to take and make this term here become 1. So I'm going to multiply top and bottom by the reciprocal of cosine s cosine t. 1 over cosine s cosine t in the top, and 1 over cosine s cosine t in the bottom. When I distribute this to all four terms, lots of canceling occurs and we'll have a nice neat result. So sine s cosine t divided by cosine s cosine t, the cosine t's cancel and I'm left with sine s over cosine s, which is tangent s. Distributing the green to the second term, cosine s over cosine s is 1 and sine t over cosine t is tangent t. In the denominator, we picked 1 over cosine s cosine t so that the first term would cancel out and we're left with just a 1. And then the second term, sine s over cosine s is tangent s, and sine t over cosine t is tangent t, so we wind up with tangent s tangent t. And that is the formula for the tangent addition. So to summarize, tangent of s plus t is tangent s plus tangent t, all divided by 1 minus tangent s tangent t. You won't need to derive that again, you'll just need to memorize that and be able to use it. The tangent subtraction formula is very similar to the tangent addition formula, except the two signs change. So the tangent of s minus t is tangent s minus tangent t, all divided by 1 plus tangent s tangent t. And like any formula, if you write it out 4 or 5 times, you'll probably get it memorized pretty quickly. Okay, so the example problems are pi over 12 is not an angle that we have memorized on the unit circle, but if we realize that pi over 12 is the same thing as pi over 3 minus pi over 4, we can use the tangent subtraction problem to get an exact answer for the tangent of pi over 12. Hopefully you can see that 1/3 is the same thing as 4/12. 1/4 is the same thing as 3/12, so 4/12 minus 3/12 is 1/12. Anyway, start by writing the formula. The tangent of pi over 3 minus pi over 4 is tangent of the first, pi over 3, and then we do subtraction, tangent pi over 4, all divided by 1 plus tangent pi over 3 tangent pi over 4. So the two angles that I need to find that I do know in the unit circle are the ordered pair for pi over 3 and the ordered pair for pi over 4. So I'll have to decide if I do my quick unit circle diagram. Pi over 3 is up near the y-axis. Its ordered pair is 1/2 root 3 over 2. Pi over 4 is the 45-degree angle. Its ordered pair is root 2 over 2 root 2 over 2. The tangent of pi over 4 is pretty easy. It's just 1. The tangent for pi over 3, I need to take the y and divide it by the x. So root 3 over 2 divided by 1/2 is the same as root 3 over 2 times 2 over 1. So that winds up equaling root 3. So now that I know that the tangent of pi over 4 is 1 and the tangent of pi over 3 is root 3, my formula simplifies into root 3 minus 1 over 1 plus root 3 times 1. So while that's a pretty good answer, most books are going to have you simplify the fraction by using the conjugate of the denominator. So the last few steps involve getting rid of this square root in the denominator. I'm going to multiply the top and bottom by 1 minus root 3. And that will, in the numerator, produce root 3 times 1 is root 3. Root 3 times negative root 3 is minus 3. Negative 1 times 1 is negative 1. And negative 1 times a negative root 3 is a plus root 3. In the bottom, 1 plus root 3 times 1 minus root 3 is 1. The two middle terms cancel out, minus root 3 times root 3 is 3. And I get 1 minus 3. So on the top I've got 2 root 3's and a minus 4. In the bottom I have a negative 2. And this produces a final answer of negative root 3 plus 2. So for the second example, finding the tangent of 7 pi over 12, it's going to be very similar to the first, except instead of subtracting pi over 3 and pi over 4, I think we're going to wind up adding pi over 3 and pi over 4. And since we've already found the tangent of both of those angles earlier, this should be a little bit faster. Again, the tangent addition formula is tangent pi over 3 plus tangent pi over 4 divided by 1 minus tangent pi over 3 tangent pi over 4. Pi over 3 tangent is root 3 plus 1 divided by 1 minus root 3 times 1. And again, I have a fraction with a denominator that involves a square root, so I need to take the conjugate again, multiply it by 1 plus root 3 in the top and in the bottom. So multiplying the top, I'll get root 3 plus 3 plus 1 plus root 3. And the bottom, 1. A positive root 3 and a negative root 3 cancel out. And then negative root 3 times root 3 is a minus 3. So again, in the top, I get 2 root 3's plus a 4. In the bottom, I get a negative 2. And that simplifies to be negative root 3 minus 2. So two very similar answers, one for the tangent of pi over 4 using the tangent subtraction formula, and one for the tangent of 7 pi over 12 using the tangent addition formula. And the final example is going back to some information from the first day. I need to take the cosine of alpha plus beta times the cosine of beta plus the sine of alpha plus beta times the sine of beta. And at first look, it seems like we need to take this and expand it out using the cosine addition formula, and this and expand it out using the sine addition formula. But if we look at the big picture and look at the pattern, you can see cosine something plus sine something, sine something. That's a formula that we've seen before. Cosine plus sine. Cosine s plus cosine, not plus. Cosine s times cosine t plus sine s sine t is the formula that we use for the cosine subtraction formula. Cosine s minus t. So I think what we can do is take this first term, call it s, take the second term, call it t. The first argument, a plus b, is the s. The second argument, beta, is the t. And now, once I observe this pattern, I say that my answer is simply cosine alpha plus beta, which is the s stuff, minus the t term, beta, and I wind up with the cosine of alpha. So that's a much shorter path to a simplified version than expanding out using the cosine addition formula and expanding out using the sine addition formula. And the moral of the story for this one is that if you see something fairly complex, don't be afraid to use the right side of those formulas to make stuff simpler. Okay, that's it for day 2.